So in this video, I want to introduce the concept of particles. Particles are used within a lot of dynamic systems as kind of like the base driver of a lot of different types of visual effects. They're used for fluid flip dynamics, ocean simulations, crowd simulations, grains of sand, and even in rigid bodies you can use particles to drive dynamic animation. They're used in a lot of places because they are, by essence, just a singular point. And so the ability to calculate and apply different sort of math and force functions to them is very calculatable. And so it's very multi-purposeful in the type of things you can use it for. But in this video, I just want to start getting into the concept of particles and emitting particles. So to get started, I'm going to create a sphere. It's always an easy thing to start with. I'm going to Control Shift that sphere. That's going to auto-create me a SOP network, a geometry SOP network. Within that SOP network, we have this sphere operator. So if I go back to the object level, and with that sphere selected in the object level, I'm going to go to the particle tab, which is the third tab in on the right tool shelf, and then the third button in source particle emitter. It's going to run some Python to create some networks. So I'm going to go back up to the object level here where it auto puts us in our auto.dot network. And here at the object level, I'm just going to click play and show you what happens. Here we have particles being created in the 3D space. So what is a particle? A particle is essentially just a point. If you have a singular particle, it's just a point. And particles grouped together in a particle animation is multiple points with multiple features added to them. So inside the scene view, if I select our source particles, which is, if we dive into here, it's just the dot import that's bringing the particles from the auto.dot network to the SOP level so they're renderable. So if I select those and look at our geometry spreadsheet, you'll see that what here in the data for what the selection is, there's a lot of points, and those points have a lot of information applied to them or attributes applied. So we have their position in X, Y, and Z, their age, the time of which they died, which is 0 because their life is very long. And as you go across here, there's all this different information. Force, their life, how long their life expectancy is, their ID, their velocity. So basically all a particle is a series of points with a bunch of attributes applied to them that define how they move in space. It's a lot of math happening. Something I want to point out is if you select the auto.dot network and you look at the geometry spreadsheet, it looks different than if you have a SOP level selected. So like if I select the sphere, it has all of the points for the sphere that we created. If we create the auto.dot network, the geometry spreadsheet changes a little. Over here on the left, we have this kind of tree menu. And to get the same information that we're getting out of the source particles, if you drop down this pop network and then select geometry here, now we're getting all of that same data. So if you're trying to look for this information within inside your auto.dot network, you just want to make sure you're in the geometry of the pop object. This information is relevant, especially when you start getting into more advanced visual effects creation. So I'm going to go back to the scene view. I'm going to dive down into the auto.dot. So I'm going to click L to lay out our nodes that we have here. And you'll notice that it looks very similar to the other networks that you've worked with in rigid bodies. Over here on the left, we have a pop object, which is the object that's being created to be run through the particle solver, the pulp solver. We have a sphere source, which is bringing in that SOP level of geometry to be the source or the emitter for the particles. We have this merge for if you want to bring in any other merges. You're welcome to delete these extra merges, but I usually just leave them in case you want to add something in. We have the pop solver, which is the actual solver that defines the rules for how the particles are going to behave, how fast they move, what they collide with, all of their details for their motion. We have another merge for if you wanted to add in a different type of dynamic simulation. Say you wanted to add rigid bodies or something within this auto.dot network. That's what this second to last merge is for. Gravity, that applies gravity of -9.8. And then our output node, which disseminates that this is the end of the tree for the auto.dot network. This is also where you would output cache files for a simulation. So by default, what gets created while applying this emitter to a sphere is we just have constant emission for this entire sphere. If we zoom in here and look, you'll see that the particles are essentially just falling through the entire body of the sphere. There's no sort of collision or anything like that because all that's happening is this sphere is being sourced as the source emitter for this particle system. So if we want to control how the particles are being emitted from the sphere, we need to look at what's being brought into the pop source for this dynamic network. We know that we created the sphere, but you can also see here, if you select the source, the SOP level that is being pulled into the source for this network is the object sphere 1. A quick way to get there, say you have a bunch of networks. If you click this arrow, it's going to automatically bring you to the selection of this node network. So I'm going to click that, and that's going to jump me up to the object level with that sphere object 1 selected. So now I'm going to dive down into that, and you'll see we still just have the sphere that's being used as the emission source. But because Houdini's modular, we can do anything to the sphere and affect the emission of these particles. Say we wanted to animate the sphere. We could alt-click the center, move down some frames. Maybe we want to move it in X. Alt-click a key, and then play through. And now we have the sphere moving with the particles following along. We could change the length of the sphere. So if I wanted to make it elongated with that animation applied, then it's kind of like a stream of particles. Anything that is happening here at this SOP level that's being brought into the AutoDOP network is what is going to emit particles, and you can see it just fills the space. So that's one way to affect your emitter, is the actual whatever your geometry looks like. But we can also say specifically from different pieces of geometry. So I'm going to go ahead and I'm going to break all of these connections and bring this back to being a sphere. Now if I wanted to just say emit particles from certain faces, we need to do something that makes the output of this SOP network to the DOP network be exactly what we want to select. So for that we can use groups. So we have our sphere, and now here in the viewport, if I'm using my selection tool, I can select a series of faces. So I'm just going to select, say these 4. So with these faces selected, I'm going to tab in a group node, which is kind of similar to a group in Maya, except it's a group based on whatever you've selected. So it could be a group of faces, it could be a group of edges, it could be a group of vertices, it could be the entire object. So here, if I select and view this group, so something that happened was I tabbed in the group over here in the network view. If you wanted to auto grab your selection here, let me delete this. So I have this selection here, you want to tab in the group in the viewport. So now you'll see it's created the same exact node, but now it has under here the selection of those faces. So with this group node selected and viewed and displayed, you'll see that it automatically highlights these faces that are within the group. And if you look at the geometry spreadsheet, it's still showing all of the points for the sphere, but if I scroll down, these points highlighted are the points are what fall on these faces. So point 39, 40, 41, 47, 48, 49, etc., etc. If I go back and look at the scene view and turn on the points, which is this little button here on the right, and zoom in on those faces. Oh, sorry, point IDs, which is this little button right here with the number, the little 12 next to it. If I zoom in, you'll see the edges, 47, 48, 49, 39, 40, 41. So this is how Houdini understands your data in space. And a similar thing happens in Maya, but it all kind of happens in the background, and to access it is kind of convoluted and requires some scripting know-how. So Houdini's very forthcoming with its information. I'm going to turn off that point numbers. So now we know how we have this group. And this group by default is called group 1. You can call this whatever you want. You could call it emitter, or if it's just a file for you, you could call it cat, whatever you want. It really is negligent in the sense of what, if it matters, it just needs to be something that you're able to identify. If you're in a pipeline situation, there probably would be some standardization of what you kind of name different groups and stuff, and you would obviously be probably annotating with notes and stuff in your network so other people in the pipeline could understand what's happening. But you'll see here under this group node now it says cat because that's what this group is defined as. So I'm going to rename the group to emitter. And then the last thing I want to do is I want to tab in a null node. And the reason I want to do that is because similar to the AutoDOP network, it's nice to kind of know when an end of a tree happens, even at the SOP level. A workflow that I typically work with is to call this out and then call it whatever it is. So this is the out for the emitter, so we know this is the output for this SOP network. So now we have that, and that's great and all. And if I play, you'll see nothing's changed. The geometry is still just emitting from the sphere. And that's because we haven't actually changed the source. We've changed what's happening in the source, but the output, when we go to the object level and click on this SOP network, you'll see is just the sphere. It didn't really do anything that changed the output, it just grouped some faces together and applied a name to that group. What we need to do is under the auto.network, in the sphere source, for the pop source, where we're sourcing in that sphere, you'll see here under the source tab, the first tab, the SOP that it's pointing to is the sphere, but then right below that you see source group. Now if I drop this down, this arrow down on the right, now we have that cat group. It would say whatever you named this group. You could have named it emitter, cake, taco, whatever. Whatever you named it, you can select here. And now you see here what happened was the source got changed to be that, not only just that object, but specifically that group. So now if I zoom out and play, now the emission is happening just from those faces. So the takeaway from this video is that whatever you create in the SOP level and import into your source for your pop source is where the particles are going to be emitted from.